The human circulatory system is an architectural marvel of biological engineering, a vast and intricate network of vessels that, if laid end to end, would wrap around the Earth more than twice. For those navigating the later decades of life, understanding the silent, complex dynamics of this internal river system becomes the ultimate key to unlocking sustained vitality, preserving independence, and reclaiming biological autonomy from the constraints of age-related decline. At the very heart of this circulatory miracle lies a profound microscopic universe, specifically the endothelium, which is the ultra-thin, single-cell layer lining the entire interior surface of our blood vessels. For centuries, the medical establishment viewed the endothelium as little more than a passive barrier, akin to the inert inner lining of a household plumbing pipe, designed merely to keep blood confined within its channels. However, modern vascular biology has radically transformed this perspective, revealing the endothelium to be the largest, most active endocrine organ in the human body, a highly intelligent sensory interface that constantly monitors blood pressure, shear stress, oxygen levels, and nutrient demands. When we are young, this endothelial layer functions with astonishing precision, orchestrating a seamless symphony of cellular signals that maintain blood vessels in a state of youthful elasticity and robust responsiveness. Yet, as the years accumulate, a silent and gradual shift occurs, often manifesting as a progressive stiffening of the arteries, a condition clinically known as arteriosclerosis. This vascular stiffening is not merely a mechanical failure. It is fundamentally a breakdown in cellular communication, and the primary language of this communication is a fleeting, invisible gas known as nitric oxide. Reversing this trajectory of age-related vascular stiffness and restoring the vibrant microcirculation necessary for total body vitality requires us to deeply understand and purposefully optimize the biological secrets of nitric oxide. To fully appreciate the magnitude of nitric oxide's role in human health, we must journey back to the late 20th century, specifically to the year 1998, when the Nobel Prize in Physiology or Medicine was awarded to three American scientists, Robert Furchgott, Louis Ignarro, and Ferret Murad, for their groundbreaking discovery of nitric oxide as a signaling molecule in the cardiovascular system. Before their meticulous research, nitric oxide was primarily known as a toxic environmental pollutant, a byproduct of car exhaust and thunderstorms. The revelation that the human body intentionally manufactures this exact same gas to regulate its most vital functions sent shockwaves through the scientific community. Nitric oxide, or NO, is characterized by its incredibly short half-life, existing in the bloodstream for merely fractions of a second before degrading. Because it is a gas, it possesses the unique ability to diffuse rapidly and freely across cellular membranes, unhindered by the traditional biochemical barriers that restrict larger molecules. When the endothelium senses the mechanical friction of blood flowing over its surface, a phenomenon known as laminar shear stress, it triggers an intricate biochemical cascade. Calcium ions rush into the endothelial cells, binding to a protein called calmodulin, which in turn activates a crucial enzyme known as endothelial nitric oxide synthase, or eNOS. This enzyme acts as a biological factory, taking an amino acid called L-arginine, which we obtain from our diet, and combining it with oxygen to synthesize and release nitric oxide. Once produced, nitric oxide instantly diffuses out of the endothelial cell and into the adjacent vascular smooth muscle cells that wrap around the artery. Inside these muscle cells, nitric oxide activates another enzyme called soluble guanylate cyclase, which converts guanosine triphosphate into cyclic guanosine monophosphate, or cGMP. It is the cGMP that serves as the ultimate messenger of relaxation, instructing the smooth muscle fibers to uncouple, lengthen, and relax. Consequently, the blood vessel widens, a process known as vasodilation. This instantaneous widening lowers the resistance to blood flow, allowing a rich, unimpeded surge of oxygen and life-sustaining nutrients to reach hungry tissues without forcing the heart to overexert itself. However, the tragedy of human aging is intimately tied to the gradual decay of this magnificent biochemical pathway. As we cross the threshold into our 50s, 60s, and beyond, our biological capacity to produce nitric oxide through the traditional eNOS enzyme pathway diminishes significantly. By the time many individuals reach the age of 40, their nitric oxide production has already dropped by half compared to their 20s, and this decline accelerates with each passing decade. This precipitous drop in nitric oxide availability is the primary catalyst for endothelial dysfunction, a condition that serves as the genesis for almost all age-related cardiovascular diseases. When the endothelium can no longer produce adequate nitric oxide, the arteries lose their youthful pliability. They remain locked in a state of chronic constriction, forcing the heart to pump harder to push blood through narrowed, rigid channels, thereby elevating blood pressure. But the damage extends far beyond mere pressure mechanics. Without the protective, anti-inflammatory, and anti-adhesive properties of nitric oxide, the endothelial lining becomes sticky and inflamed. Circulating white blood cells and oxidized cholesterol molecules begin to adhere to the vessel walls, infiltrating the subendothelial space and initiating the formation of atherosclerotic plaques. Furthermore, the structural matrix of the blood vessel undergoes a detrimental transformation. In a low nitric oxide environment, the production of elastin, the protein that gives arteries their stretch, declines, while the deposition of rigid collagen fibers accelerates. This fibrotic shift turns once flexible arteries into rigid tubes, incapable of absorbing the pulsatile force of the heartbeat. This profound loss of arterial elasticity is what we experience externally as a decline in stamina, the onset of chronic fatigue, cold extremities, and a general waning of vitality, as the vital organs are slowly starved of the optimal blood flow they require to function at their peak. The consequences of this vascular stiffening are most devastatingly felt at the extreme edges of our circulatory system, in the microscopic realm of the microcirculation. While large arteries like the aorta or the carotids act as the major highways of the body, the true destination of our blood, the precise location where life is sustained, is the capillary beds. These capillaries are incredibly narrow, often so small that red blood cells must physically deform, folding themselves into parachute shapes just to squeeze through in single file. This is the last mile of nutrient delivery, where oxygen is traded for carbon dioxide, where glucose is handed over to muscle cells, and where metabolic waste products are hauled away. Nitric oxide is absolutely essential for keeping these microscopic floodgates open. When systemic nitric oxide levels plummet due to aging, the microvasculature constricts and collapses, effectively shutting down the nutrient supply lines to vast territories of tissue. In the brain, this translates to diminished cerebral blood flow, accelerating the shrinkage of brain volume and contributing to the memory lapses, brain fog, and cognitive decline that many older adults fear is an inevitable part of aging, a process intricately linked to vascular dementia. In skeletal muscle, the loss of capillary density deprives the mitochondria, the energy powerhouses of the cell, of the oxygen they need to generate ATP, resulting in the progressive loss of muscle mass and physical weakness known as sarcopenia. In the skin, reduced microcirculation leads to the thinning, wrinkling, and loss of youthful glow associated with advanced age. Therefore, when we speak of restoring systemic vitality and reclaiming biological autonomy for the elderly, we are fundamentally talking about rescuing the microcirculation. We must find a way to bypass the broken, aged eNOS pathway and flood the body with the nitric oxide it so desperately needs to reopen those collapsed capillary beds, ensuring that every cell, from the neurons in the brain to the muscle fibers in the legs, is bathed in a continuous, life-giving flow of highly oxygenated, nutrient-dense blood. Fortunately, human biology has a remarkable built-in redundancy, a secondary, entirely different pathway for generating nitric oxide that does not rely on the failing eNOS enzyme. Understanding and harnessing this alternative route is the absolute cornerstone of anti-aging vascular therapy. This pathway is known as the enterosalivary nitrite-nitric oxide pathway, and it relies heavily on selective, nitrate-rich nutrition and a deeply symbiotic relationship with the microbiome that resides in our mouths. When we consume specific vegetables that are naturally high in inorganic nitrates, such as dark leafy greens like spinach, kale, Swiss chard, arugula, and particularly root vegetables like beetroot, we are ingesting the raw biochemical precursors necessary to rescue our vascular system. Unlike the L-arginine pathway, which becomes severely compromised as we age, this nitrate pathway functions independently of our cellular enzymes, making it a highly reliable and incredibly powerful tool for older adults. The process begins the moment we chew these nitrate-rich foods. The nitrates are absorbed through the upper intestines into the bloodstream, where they circulate until a large portion is actively extracted from the blood by the salivary glands. These glands concentrate the dietary nitrate up to 20 times the level found in the blood and secrete it back into the mouth through our saliva. Here is where the true biological magic occurs. Humans do not possess the necessary enzymes to break down this nitrate, but the commensal, beneficial bacteria living in the deep crypts of the tongue do. These specific oral microbes possess a specialized enzyme called nitrate reductase. As we swallow our nitrate-rich saliva, these bacteria eagerly consume the nitrate, stripping away one oxygen atom and converting it into nitrite. This newly formed nitrite is then swallowed down into the harsh, highly acidic environment of the stomach. The moment the nitrite hits the gastric acid, the low pH environment acts as a chemical catalyst, instantly protonating the nitrite and transforming it directly into pure nitric oxide gas, along with other beneficial nitrogen oxides. These molecules are then readily absorbed back into the systemic circulation, causing a massive, reliable, and sustained dilation of the blood vessels, effectively bypassing the aged, dysfunctional endothelium. The profound implications of this symbiotic relationship between our diet, our oral microbiome, and our cardiovascular health cannot be overstated, especially for the elderly population seeking to restore their vitality. However, this delicate biochemical chain is incredibly vulnerable to modern lifestyle habits, many of which are aggressively marketed as healthy. The most catastrophic disruption to the nitric oxide salvage pathway is the daily use of antiseptic, antibacterial mouthwashes. Millions of older adults routinely rinse their mouths with harsh chemicals designed to kill all bacteria, operating under the misguided belief that a sterile mouth is a healthy mouth. In reality, these antimicrobial washes indiscriminately decimate the population of beneficial nitrate-reducing bacteria on the tongue. When these bacteria are eradicated, the biological bridge is destroyed. Dietary nitrate can no longer be converted to nitrite, and the entire enterosalivary pathway comes to a grinding halt. Clinical studies have clearly demonstrated that individuals who use antibacterial mouthwash experience a significant and measurable spike in their blood pressure within mere hours of use, entirely due to the sudden, chemically induced depletion of systemic nitric oxide. Similarly, the widespread, chronic use of proton pump inhibitors and over-the-counter antacids, medications commonly prescribed to seniors for acid reflux or heartburn, poses a devastating threat to this process. By artificially suppressing the production of stomach acid, these drugs eliminate the highly acidic gastric environment necessary for the final chemical conversion of nitrite into nitric oxide. Consequently, even if an older adult consumes a perfectly healthy, nitrate-rich diet and maintains a flourishing oral microbiome, the absence of stomach acid will trap the molecule in the nitrite stage, preventing the life-saving burst of vasodilation. To truly optimize this pathway and recover vascular elasticity, individuals must prioritize the daily consumption of high-nitrate foods, ideally roasted or steamed, as boiling leaches the water-soluble nitrates into the cooking water, while fiercely protecting the ecology of their oral microbiome by abandoning antiseptic mouthwashes, using fluoride-free toothpastes, and working with their healthcare providers to find alternative solutions for gastric distress that do not permanently paralyze. Stomach acid production. Beyond merely supplying the raw materials for nitric oxide production, a comprehensive strategy for vascular rejuvenation must also fiercely protect the nitric oxide molecules once they are created. As previously noted, nitric oxide is exceptionally ephemeral, and its greatest enemy is a biological state known as oxidative stress. As our bodies age, our natural antioxidant defense systems weaken, and we begin to accumulate high levels of reactive oxygen species, commonly known as free radicals. The most pernicious of these is the superoxide radical. Superoxide is a highly unstable, highly destructive molecule that aggressively seeks out and binds with nitric oxide in a fraction of a millisecond. When superoxide and nitric oxide collide, they destroy each other, forming a highly toxic, tissue-damaging compound called peroxynitrite. Not only does this reaction completely eliminate the beneficial, vasodilating effects of nitric oxide, but the resulting peroxynitrite acts as a cellular wrecking ball, tearing through the endothelial lining, damaging DNA, and causing severe uncoupling of the eNOS enzyme. When eNOS becomes uncoupled, it undergoes a tragic biological malfunction. Instead of producing nitric oxide, it begins to manufacture even more superoxide, creating a self-perpetuating, vicious cycle of oxidative damage and rapid vascular aging. To break this cycle, the elderly must fortify their internal environment with a massive, continuous influx of targeted dietary antioxidants. Vitamin C, particularly when consumed in its natural, whole food matrix alongside bioflavonoids, is a potent defender of nitric oxide, neutralizing superoxide radicals before they can attack. Vitamin E, acting within the lipid membranes of the cells, prevents the oxidation of cholesterol, further reducing the inflammatory burden on the endothelium. Even more powerful are the complex polyphenol found in dark berries, pomegranates, green tea, and high-quality dark chocolate. These phytochemicals do not merely scavenge free radicals. They interact directly with human DNA, activating a genetic master switch known as NRF2, which commands the body to drastically ramp up its own production of endogenous, highly potent antioxidants like glutathione and superoxide dismutase. By flooding the system with these synergistic nutrients, we create a biochemical shield, ensuring that the nitric oxide produced, whether through the physical stimulation of the endothelium or the dietary nitrate pathway, survives long enough to reach the smooth muscle cells and trigger the deep, restorative relaxation of the arterial network. Equally critical to the chemical composition of our blood is the physical, mechanical state of its flow. While nutrition provides the building blocks and the protective shields, physical movement provides the indispensable mechanical signal that forces the vascular system to adapt, heal, and expand. For the elderly, the concept of exercise must be reframed. It is not simply about building large muscles or burning calories, it is fundamentally a localized, fluid dynamic therapy for the blood vessels. When we engage in sustained physical activity, whether it is a brisk walk in the park, a cycling session, swimming, or the mindful, flowing movements of Tai Chi, our heart rate elevates, and the volume of blood rushing through our arteries increases exponentially. This surge in blood flow creates a frictional force against the endothelial lining. The endothelial cells are equipped with microscopic, hair-like structures known as the glycocalyx, which act as highly sensitive mechanoreceptors. As the rushing blood bends these delicate structures, it signals the interior of the cell to rapidly phosphorylate the eNOS enzyme, turning on the biological faucet to release a massive flood of nitric oxide. This phenomenon explains why blood vessels visibly bulge during exercise. It is the immediate, life-saving vasodilation required to deliver oxygen to working muscles. However, the benefits of this sheer stress extend far beyond the duration of the exercise itself. Regular, daily physical activity causes a profound structural remodeling of the entire vascular tree. The sustained exposure to elevated nitric oxide levels stimulates angiogenesis, the actual sprouting and growth of entirely new capillary networks within the muscle tissue, the heart, and the brain. This expansion of the microcirculation fundamentally reverses the age-related collapse of the capillary beds, drastically shortening the last mile of nutrient delivery. Furthermore, the sheer mechanical stretching of the arterial walls during exercise stimulates the cells to produce more elastin and degrade the stiff, fibrotic collagen, literally reversing the physical hardening of the arteries. For an aging adult, adopting a consistent routine of moderate, joy-filled movement is the most potent mechanical intervention available to clear out stagnant blood, forcefully sweep away adhering cholesterol particles, and demand that the vascular system return to a state of dynamic, youthful plasticity. Yet, any holistic discussion of restoring biological vitality would be woefully incomplete without addressing the profound, often overlooked connection between our psychological state and our vascular health. The human brain and the circulatory system are intimately intertwined, locked in a continuous, bidirectional conversation mediated by the autonomic nervous system. As people age, they often face a unique set of psychological stressors: grief from the loss of loved ones, anxiety regarding financial security, the psychological burden of chronic illness, and the deep-seated existential fear of losing independence. When the brain perceives these emotional or psychological threats, it activates the sympathetic nervous system, initiating the ancient fight-or-flight response. The adrenal glands flood the bloodstream with stress hormones, primarily cortisol and adrenaline. These hormones bind to alpha receptors on the blood vessels, commanding them to instantly and violently constrict, an evolutionary adaptation designed to prioritize blood flow to the major muscles for immediate physical survival. However, in the modern context, where the stressor is chronic and emotional rather than acute and physical, this continuous state of vascular constriction becomes a physiological disaster. Chronic stress continuously overrides and suppresses the parasympathetic nervous system, the rest and digest state, severely inhibiting the endothelium's ability to produce nitric oxide. The constant barrage of cortisol directly impairs the eNOS enzyme and drastically increases systemic inflammation, accelerating the stiffening of the arteries. This is why periods of intense grief or sustained anxiety can literally trigger cardiovascular events. The emotional trauma physically strangles the blood supply. Conversely, this neurological connection offers a magnificent pathway for healing. Mind-body practices such as deep, diaphragmatic breathing, meditation, prayer, and the cultivation of gratitude are not merely abstract, feel-good concepts. They are highly effective, scientifically validated vascular therapies. When an older adult engages in slow, controlled, deep breathing, it stimulates the vagus nerve, which runs from the brainstem down through the abdomen. Vagal stimulation instantly dampens the sympathetic nervous system, halts the release of stress hormones, and triggers a massive systemic release of nitric oxide. The blood vessels relax, blood pressure plummets, and the heart rate slows to a peaceful, rhythmic pace. Teaching the elderly to actively manage their psychological landscape, to foster emotional resilience, and to find moments of profound mental stillness is just as critical to reversing vascular stiffness as prescribing the perfect diet or the ideal exercise routine. The pursuit of deep, restorative sleep is the final, non-negotiable pillar in this comprehensive strategy for vascular rejuvenation. Sleep is not a passive state of biological inactivity. It is a highly active, metabolically intense period during which the body performs its most critical repair work. During the deepest stages of non-REM sleep, blood pressure naturally dips, taking the mechanical stress off the endothelial lining. This nightly hypotensive window allows the endothelial cells to focus their cellular energy on repairing the damage incurred during the waking hours. In this nocturnal state, the body dramatically upregulates its production of endogenous antioxidants, sweeping up the accumulated free radicals and giving the nitric oxide pathways a chance to reset and regenerate. Furthermore, optimal sleep is absolutely essential for regulating the delicate balance of hormones that govern appetite, insulin sensitivity, and systemic inflammation, all of which indirectly but powerfully impact vascular elasticity. Unfortunately, aging is frequently accompanied by a severe disruption in sleep architecture, characterized by difficulty falling asleep, frequent nighttime awakenings, and a drastic reduction in deep, restorative slow-wave sleep. This sleep fragmentation denies the vascular system its crucial repair window, leading to a state of chronic, low-grade sympathetic activation that persists into the daylight hours, perpetually suppressing nitric oxide production. Addressing sleep hygiene by optimizing the sleep environment to be cool, completely dark, and quiet, by strictly avoiding the blue light emitted by digital screens in the hours before bed, and by establishing a consistent, calming evening routine, is an indispensable component of the nitric oxide protocol. When an aging individual succeeds in restoring deep, unbroken sleep, they awaken not just feeling mentally refreshed, but with a vascular system that has been physiologically recalibrated, fully armed with an optimized reserve of nitric oxide, ready to efficiently dilate and adapt to the physical and emotional demands of the new day. Ultimately, the journey to reverse vascular stiffness and reclaim total body vitality in our later years is not a search for a singular, magic pill. It is a profound, empowering shift in how we understand and interact with our own biology. It is the realization that the symptoms of aging, the fatigue, the cognitive slowing, the physical frailty, are very often not predetermined, unalterable genetic decrees, but rather the highly preventable consequences of a starving microcirculation. By elevating nitric oxide to the center stage of our health philosophy, we are given a clear, actionable roadmap to cellular restoration. We bridge the gap between microscopic cellular signaling and macroscopic, systemic vitality. Through the deliberate daily consumption of nitrate-rich earth foods, the fierce protection of our symbiotic oral microbiome, the targeted use of synergistic antioxidants, the joyful engagement in regular physical movement, and the mindful cultivation of emotional peace and deep sleep, we orchestrate a spectacular rescue mission for our vascular network. We forcefully reopen the collapsed capillary beds. We dissolve the stiffened, fibrotic matrix of our arterial walls, and we restore the youthful, dynamic elasticity that allows our blood to flow like a vibrant, rushing river. This is the ultimate secret of nitric oxide. It is the master biological key that unlocks the door to sustained, vibrant longevity, allowing us to traverse the golden years of our lives not with trepidation and physical decline, but with profound biological autonomy, radiant energy, and a circulatory system that remains, to our very last breath, fiercely and resiliently alive.